Welcome to the viewers. We discuss today the idea of Bessel's equations and indicial equations to find out. Then in the next video we find out the solution of the Bessel's equation. Let's discuss very much important topic. Bessel's equation. And this Bessel equation, the differential equation, is given by z square w double dash plus z w dash plus z square minus gamma square w equals to 0, and where this gamma is a real or complex constants. We called this equation as Bessel equations. Now clearly, if we compare with this equation, if we taking it equation number 1, comparing it with w double dash plus pzw dash plus qzw equals to 0, taking it equation 2, and where it is clear that all w dash, that is dw dz, all are functions of z and with respect to derivative z. That's why all complex valued functions we have. So it is clear pz will be, if we divide it, that is 1 by z, and qz will be z square minus gamma square by z, and it should be noted as, if we divide it from 1, w double dash plus 1 by z w dash plus z square minus gamma square by z, w equals to 0. And if we take as pz and qz, comparing with this value, we are getting this pz and qz. And now we are going to the concept of some complex analytics functions. We recall it in reference to the study of any standard book of complex analysis, and we considering the product we have from here, zpz is equal to 1, and also z square qz, that is equals to z square minus gamma square. From these two we are calculating, and so z equals to 0, and it is clear the concept of pole, that is there are different type of singularities, and that detailed will be studied in complex analysis part, and where we study it clearly. But now we apply this process to find out the Bessel's equations and finally indicial equation, and then after in next videos we find the solution of the equations. Now here we calculate z equals to 0, and it is a pole of pz and also pole of qz, and both pz, that is zpz, and z square qz are analytic at z equals to 0, It is clear. There is no singularity. So it is clearly an analytic function. And z equals to 0 is a regular singular point of differential equation z square w double dash plus z w dash plus z square minus gamma square w equals to 0. It is clear, where gamma is a real or complex constants. And now finally we find the indicial equation. Indicial equation for Bessel's. How to find it? And if we consider the indicial equations, alpha into alpha minus 1, considering this product, plus p0 alpha, and that is already we find z into 1 zpz plus q0, that is minus of gamma square, equals to 0, and it should be noted here. Indicial equation alpha into alpha minus 1 plus alpha p0 plus q0 equals to 0. And but it is clear here that is p0, and if we noticed it, it is clearly 1. And if we find it like zpz, from zpz and an analytic function, we find it at z equals to 0, that is if we find like the root of p0, that is p0 at z equals to 0 terms, if we consider it, and already being put as 1, and q0 if we find, that is already we find zpz, and it is also clearly written z minus 0 into 0. That's why these things happen. And here it is z minus 0 whole square into p0, that is z equals to this type of z equals to 0. If we consider, that is 0 square minus gamma square, so it will be minus of gamma square. It should be noticeable. That is the point near about 0, and details discussion is given in complex analysis part, especially for pole and polar section, and always reference to the part of complex analysis, because there is some of the complication z minus 0, that is point near about origin. That's why. But sometimes it is perplexed that this type of z and this z are same, but actually this is the point. If we some point of complication, we considering it, suppose z something near about the point z0, that's why this point is taken as 0, so it will be 1, and z square is treated as z minus 0 whole square, that is minus of 0 square minus gamma square, that's why it is minus gamma square. Then the indicial equation is alpha square minus alpha plus alpha minus gamma square equals to 0, that is alpha equals to plus minus gamma. And in my next video we finally find the root of the solutions, and with the on the basis of this root we calculate the general solution of Bessel's equations. It is in my next videos. Keep watching. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.